In the silent dark beyond the sun, something is happening right now that no one on Earth can see. For the next 72 hours, an interstellar object called 3I/Atlas is hidden behind the sun, completely invisible, completely unobservable. And when it reemerges, it could challenge everything scientists believe about comets, interstellar travel, and even the possibility of artificial objects entering our solar system. Because before it disappeared, Atlas broke 5 rules of nature. This is the countdown. Far out in the void between the stars, an object that doesn't quite belong has been moving toward our sun. Known as 3I/Atlas, it is only the 3rd confirmed interstellar visitor in human history. A cosmic traveler born around a distant star, drifting for millions of years before slipping into our solar system. Right now, Atlas is at solar conjunction, positioned directly behind the sun from Earth's perspective. Every telescope on Earth is blind. Every probe is out of sight. For the next 3 days, humanity has no idea what Atlas is doing. And that uncertainty is fueling speculation, urgency, and scientific debate unlike anything since the discovery of Oumuamua, the hidden visitor. Atlas followed the 2 legendary interstellar objects that came before it. Oumuamua, long, tumbling, and utterly mysterious. Borisov, icy, bright, and reassuringly normal. But Atlas? Atlas is something else entirely. Just before slipping behind the sun, it began displaying behaviors no natural comet should show. Its trajectory, its chemistry, its structure, they all raised difficult questions with no clear answers. And now, during these 72 unobservable hours, scientists wonder, what is Atlas doing out of sight? And what will it look like when it returns? The 5 anomalies. Before the blackout, researchers documented 5 anomalies. 5 reasons some scientists believe Atlas may not be a typical interstellar comet at all. 1. The impossible alignment. Interstellar objects can enter the solar system from any direction. Yet Atlas arrived almost perfectly aligned with the ecliptic plane, the thin slice of space where Earth and the other planets orbit. The probability of such alignment by chance is incredibly small, like throwing a dart across the galaxy and grazing the edge of a sheet of paper. 2. The industrial signature. Spectroscopic observations revealed nickel emission lines in unusual concentrations, more typical of refined metal than frozen cometary material. One scientist described it as looking less like a dirty snowball, more like the exhaust of a forge. 3. The dry traveler. Unlike typical comets rich in ice and water, Atlas appears shockingly dry. Its reflective signature displays polarization patterns seen in structured, geometric surfaces, something far more orderly than random chunks of ice. 4. The giant. Atlas is large, much larger than Oumuamua or Borisov. A mass this substantial raises the possibility, however remote, of internal structures or compartments protected during interstellar travel. 5. The anti-tail. Most comets produce tails pushed away from the sun, but Atlas developed an anti-tail material shooting forward toward the sun. That requires internal force. Outgassing could do it, but the persistence and power of Atlas's anti-tail has left researchers uneasy. These 5 anomalies triggered something unprecedented. The protocol activation. Atlas was assigned a level 4 rating on a scientific scale used to evaluate potentially artificial interstellar objects. Nothing in history has scored this high. That rating quietly activated planetary defense observation protocols, systems normally reserved for dangerous near-Earth objects. Not because Atlas threatens Earth, its trajectory isn't even close, but because its behavior demands the most intense monitoring humanity can muster. For the first time, these systems are being used not to prepare for an impact, but to answer a question. The hidden images. Before solar conjunction, NASA's Mars Reconnaissance Orbiter captured high-resolution images of Atlas, images far sharper than anything taken from Earth. Those images have not been released. The European Space Agency has revealed parts of its own data, showing a seemingly normal comet, But embedded within that data are the same anomalies, the same strange chemistry, the same unusual emissions, the same structural mysteries. Why the selective releases? What did the MRO see? And what will we discover when Atlas reappears? For scenarios, scientists now debate for main explanations, ranging from conservative to extraordinary. 1. Exotic but natural. Atlas may be a completely natural object formed in a star system with chemistry nothing like our own. Strange, yes, but still natural. 2. Controlled fragmentation. Some theorize its unusual emissions and anti-tail could indicate a programmed release of internal components, like a spacecraft deploying instruments. 3. Orbital maneuver. If Atlas's trajectory changes after re-emerging, it could indicate non-gravitational acceleration, the kind expected from active maneuvering. 4. Ejection event. Perhaps Atlas is shedding probes or smaller payloads during perihelion, sending them on separate paths through the solar system. These are not claims, just possibilities, but possibilities worth considering. The divided community. The scientific world is split. Harvard's Avi Loeb argues that Atlas's anomalies deserve serious, open-minded investigation. Others, like Jason Wright, insist nature can surprise us, and rare doesn't mean artificial. Both sides agree, we need more data, and in 72 hours, that data will begin to arrive. The countdown. When Atlas emerges from behind the sun, 3 major observation windows will open. 1. The JWST probe. ESA's Jupiter mission will view Atlas from a unique angle impossible from Earth. 2. Closest approach. Several weeks later, Atlas will be closer to Earth than ever before, allowing unprecedented imaging and spectroscopy. 3. The Juno encounter. NASA's Juno spacecraft will capture a final distant look as Atlas heads back toward interstellar space. If Atlas changes course, if fragments separate, if its emissions shift, those moments will reveal it. Conclusion. In 72 hours, the blackout ends. In 72 hours, humanity will see Atlas again. It may behave exactly as a comet should. Strange but natural. Or it may do something no comet has ever done. It may shift, split, accelerate, or reveal structures hidden from the sunlit side. Right now, in the darkness beyond our star, something is happening. And when the first light returns to Earth's telescopes, we may learn whether Atlas is simply unusual, or unusual for a reason. The countdown has begun.